Welcome to Launch Control. This is where we make sure our rockets take off safely. We're working on a really exciting project called the Artemis program, and we want you to be a part of it. We've made some special classes just for you that will teach you everything you need to know about building rockets and the Artemis program. And we have a special mission for you to practice your skills. This will get you ready for when we start sending cargo and even people to the moon. The first mission you'll be working on is launching a satellite into space. This satellite will help us communicate with our spacecraft when we fly to the moon. It's an important step in our mission, and you'll be playing a big role in making it happen. Alright, if you're ready to get started with the lessons, head down the hallway and through the first door. That's where the classroom is. Once you're there, just talk to the teacher and they'll get you started on learning all about why we're going to the moon.
Hi, I'm a cryogenic engineering technician at NASA. It's my job to make sure that the fuel for the rocket is safe for launch. Our team sometimes has to fix potentially dangerous leaks.
Welcome to the Artemis Rocket build world. I'm here to tell you about the Artemis missions. NASA is going to land the first woman and person of color on the moon as part of these missions. They will use new technologies to explore more of the moon than ever before. NASA will also work with other companies and countries to set up a permanent base on the moon. What we learn from our time on the moon will help us send astronauts to Mars for the first time. Why are we going back to the moon? Why is NASA sending people there again? Click below to find out. When you're done, move on to the next section to learn about how to build rockets. The Artemis missions will help create new jobs and industries on the moon, and help people learn new skills. You have completed my lesson. Go through the door and to learn about how a rocket works.
Before we start building our own rocket, let's talk about the basics. Engineers use special laws called Newton's laws to understand how forces work and make sure rockets fly properly. These laws were first written down by a scientist named Sir Isaac Newton a long time ago, but they're still very important for rocket engineers today. Do you want to know more about Newton's laws and how they help us build rockets? Let's find out. Objects like to stay still or keep moving unless something else makes them change. For example, if our rocket is standing still and if we don't push it, it will stay still. But if we give it a push, it will keep moving until something else makes it stop. This is called Newton's first law of motion. It's important for us to understand this when we're building and flying rockets. Did you know that how quickly an object speeds up or slows down or changes direction depends on how much mass it has and how hard it is pushed? This is called Newton's second law of motion. If we want to make a rocket go faster, we can either make it lighter or push it harder. Have you ever heard the saying, every action has an equal and opposite reaction? Well, this is a scientific idea, called Newton's third law of motion. It means that when something pushes or pulls on something else, the second thing pushes or pulls back just as hard. This is how we can make things move, like rockets. A rocket engine produces thrust through action and reaction. Friction, the engine produces hot exhaust gases which flow out of the back of the engine. Reaction, a force is produced in the opposite direction from the fuel pushing back on the rocket. When we're building and flying rockets, it's important to think about the different forces that will be acting on it. These forces can push or pull the rocket in different directions. and some forces are stronger than others. For example, the force of gravity is always pulling the rocket down towards the ground, and the rocket's engines create a force called thrust that can push the rocket up into the sky. To make sure our rocket flies the way we want it to, we need to think about how all these forces will affect it. Weight is the force that the Earth's gravity creates on an object. Gravity causes a mass to have weight and is what makes things fall to the ground. The Earth is big and heavy, so it has a lot of gravity. That's why everything weighs something here on Earth. But did you know that weight can be different on different planets? You want to build a rocket that can fly all the way to the moon. The moon is really far away, so we need to make sure our rocket goes fast enough to get there. We also need to make sure we have enough fuel to burn to power the rocket. That's because the rocket needs to go fast enough to escape the Earth's gravity. Gravity is the force that makes everything fall to the ground. To break free of the Earth's gravity, we need to go fast. Can you guess how fast we need to go? After we learn more about how fast we need to go and how much fuel we need, we can start building our rocket to fly to the moon. This means the speed of something in a certain direction. This is a short way to refer to a change in velocity. We'll be starting from 0 and accelerate to 6 ms/sec, 9.7 km/sec. Going that fast, you could go from New York to San Francisco in just 8 minutes. We'll be burning our rocket fuel to achieve our Delta V goal. You have completed my lesson. Go through the door and to learn rocket propulsion methods and fuels.
We now know about forces on our rocket, velocity, and delta V. We have a lot of stuff to bring with us, so our rocket is going to be pretty heavy. Remember, not only do we need to bring our spaceship astronauts and enough fuel to launch our rocket, we also have to bring enough fuel to get back. A rocket with more mass will speed up more slowly, so we're going to need a lot of fuel. Humans have been experimenting with rockets for thousands of years. Early propulsion engines were developed in Greece around 400 BC. The first true rockets were created in China about 800 years ago. Over the years, rockets have taken on many shapes. The fuel burned in these rockets can be liquid or solid. On Earth, many cars on the road are powered by engines that convert liquid fuel into energy to produce motion. You may be familiar with some forms of liquid fuel such as gasoline, kerosene, diesel, alcohol. Our rocket will be partially powered by liquid hydrogen. Let's take a closer look at the parts of the Artemis Space Launch System SLS rocket. Starting with the sides, we have the solid rocket boosters. The SLS has two solid rocket boosters that burn approximately 6 tons of solid fuel each second to help lift the enormous rocket off the launch pad and send it soaring to space. Their job is finished in just 2 minutes. Inside the large central section called the core stage are 2 liquid propellant tanks holding liquid hydrogen fuel and liquid oxygen. At the base are 4 large R525 rocket engines. These engines, together with the boosters, accelerate the rocket to more than 17,000 mph, 27,359 kph during the first 8 minutes of flight. The top of the rocket is where the Orion spacecraft is located. The long nose of the rocket contains the launch abort system that can activate on a moment's notice to pull the Orion crew to safety in an emergency during launch. The rocket is huge. You'll see for yourself in a few minutes, but not all of it will make it to Moon. Once the core stage propellant is spent, the empty tanks are just unnecessary weight, so they drop off to make the rocket lighter. This is called staging. Once launched, the solid boosters do their job in about 2 minutes, then fall away, splashing into the Atlantic Ocean. The core stage of the rocket, using liquid hydrogen and liquid oxygen fuel, separates about 6 minutes later, splashing into the Pacific Ocean. At this point, all that's left is the upper stage of the rocket called Interim Cryogenic Propulsion Stage IPS and the Orion spacecraft. About 50 minutes into the flight, the IPS fires briefly to raise Orion's orbit. It fires again about 30 minutes later to push Orion out of Earth orbit on a trajectory toward the Moon and separates from Orion. Fit about 2 hours into the flight, the Orion spacecraft separates and continues its journey to the Moon. You have completed my lesson. Go through the door and the next Artemis missions.
Artemis is planned to include several missions. Artemis I was successfully completed in December 2022 with the return of the uncrewed Orion spacecraft. This launch proved the technology and paves the way for the crewed missions. Learn more about Artemis I below. Currently scheduled for 2024, Artemis I will carry a 4-member crew of astronauts farther than any humans have been into space for. 600 miles, 7,402 kilometers, beyond the far side of the Moon. The 8-10-day mission will include testing Orion systems that enable the crew to live in space, demonstrating operations needed for future missions, orbiting the Moon, and collecting data before returning to Earth. Currently scheduled for 2025, Artemis I will be the first crewed moon landing since Apollo in 1972. Astronauts aboard Orion will dock with and transfer to the human landing system to visit the Moon's South Pole region. The crew will remain in space for about a month before returning to Earth. Let's review some terms before you head into the vehicle assembly building. Orion spacecraft. The NASA spacecraft that will carry astronauts from Earth to lunar orbit and back. Space Launch System Pocket. The only rocket that can send Orion, astronauts, and cargo to the Moon on a single mission. The L is the most powerful rocket that's ever flown to space. Gateway. The space station orbiting the Moon where astronauts will live, conduct science, and prepare for lunar surface missions on regular Artemis missions. Gateway will orbit the Moon for at least 15 years, supporting long-term science investigations and human discovery on and around the Moon in deep space. Human Landing System. Starship Human Landing System, provided by SpaceX. The human landing systems are the final mode of transportation that will take astronauts from lunar orbit to the surface and back to orbit. Artemis Base Camp. Artemis Base Camp is a concept that includes all the elements astronauts will need to explore and conduct science on the Moon. The base camp may be in one fixed location or distributed across a broader area on the lunar surface. It may include a modern surface habitat, a rover, a mobile home and laboratory, power generation and storage, and all the tools and equipment astronauts will need to live and work on the Moon. You have completed my lesson. Go through the door and head to the elevator to get started with building a rocket.
Hi, as the lead animator and illustrator at NASA, I transform technical blueprints and pencil drawings into accurate scale digital 3D models used for posters, infographics, engineering, documents, presentations, augmented reality, websites, animations, videos, and more.
Hi, I'm the SLS Flight Software Design Team Lead. I write code that helps get the vehicle into space.
You can now select the rocket parts you want. Each part has a different value. After you are done, press the test button, which will run our simulation. Welcome to the upper stage building hangar. Here you can redesign the upper stage the way you want to. You can only build within the area marked with blue dots. When you'll be done, come back to me to confirm your build. Awesome work! Are you happy with the upper stage? Now it is time to paint the rocket. I will hand you a spray can. You can change the color and the scale of the spray can with your inventory items. When you'll be done, come back to me to confirm your rocket, and then we will start the launch. Looks stunning. Are you ready to go?